Alright, for our next section, we will be solving exponential equations. And we've got a four-step process here, and one would be to rewrite each equation using a common base. And then we're going to use our properties of exponents to simplify each side of the equation, and then our one-to-one property. And that's telling us that if b raised to the x power equals b raised to the y power, then we know that x has to be equal to y. And once we do that, we have a situation where we can solve. So let's look at some examples. For the first example, notice they're giving us several different types of problems, but the key part here is you have a common base with each one. And so since our bases are exactly the same for each side of the equation, then we just set our exponents equal to each other. So we're going to have 2x minus 9 equals 7. And then solving this, of course, we'll need to add our 9 over and divide by 2, so x is 8. So now moving on to the next problem, number 2. It's still the same idea. We have the same base here, so all we need to do with the same bases would be to set those exponents equal to each other. So 4w minus 1 equals 5 minus 2w. I would go ahead and add that 2w over, and then we're going to add our 1 over. And notice that w in this case would have to be equal to 1. Now moving down here to our next example, we don't have just a single base, we've got these two. And remember, if you multiply with like bases, you need to add your exponents. So we have c minus 1, that's that first exponent, plus our second exponent, so that's going to be 3c plus 2. And so there's where we've added our two exponents. We know we're going to have to do that. And then those are equal to 7c plus 16. Now the rest of this is our algebra where we are combining our like terms. So that's going to give me 4c. Then I have a negative 1 and a positive 2, so plus 1 equals 7c plus 16. And now we're solving our equations, and I'm going to move my 7c over, so that's going to give me negative 3c. And then I'm going to subtract 1 over, so I'm going to have 15. So it looks like c has to be equal to negative 5. All right, moving on to our next example. Here again, very similar process. We do have a common base, but notice here we're multiplying with like bases. So we're going to have to add those exponents. And adding those, we have k squared plus k. And then we're going to add to that 2k minus 9. And then over on the other side, we have 4k plus 11. So on the left side, we can try to combine some of our like terms. Now, of course, nothing's going to combine with k squared, so we're going to bring that down. And then a positive k plus 2k, so that's positive 3k minus 9 equals 4k plus 11. We do need to get everything moved over to the left side, and so it looks like we're going to have a factoring situation. So we're going to have k squared and minus k, and then I'm going to subtract 11 over, so that's going to give me negative 20, and all of that equals 0. So now we need to factor this, and we should have k minus 5 times k plus 4 equals 0. And so it looks like we're going to have k is equal to 5, and then k is equal to negative 4. So there's our two solutions. Now our next type of problem, we do not have the same bases. So we are going to have to change those bases to be something that we can have that are similar on both sides. So a couple of ways you can do this. Now we need to change what the number looks like, not the value of the number. So changing the value, we have to be careful. Most of the time you will be picking on the larger base. And so notice that 81 can be rewritten as 9 raised to the second power, and that's going to help us with rewriting, because I didn't change the value, I just changed the appearance of the number. So for number 5, if we did rewrite that other side, we would have a common base. So we have 4y minus 26 equals 9 squared. So now we're back to having that common base, and so we will be setting these exponents equal to each other and solving. So 4y minus 26 equals 2. I'll add 26 to the other side. Divide by 4, and so we see that y is 7. Okay, moving on to the next problem. Again, very similar process here. I would be choosing to change 1 over 64, and that way we're not changing the value. So to rewrite that in terms of 4, well, I know I need a negative exponent so we can get a reciprocal, and I also know that 4 raised to the third power is 64. So I'm going to rewrite all of this with 4 to the negative 3. And again, I did not change the value of that base, I just changed how it looked. Now I'm going to set each side equal to each other, and here notice I need to add 4 over, and so if I do that, I have a positive 1 equals a squared. I'll take the square root of both sides, and so I have positive or negative 1 for an answer. Okay, number 7. Again, going through similar process here. I will be changing 32, and so I have 2 raised to the m minus 9, and then 32 is 2 to the 5th, but I already have some exponents there, so I'm going to use that exponent rule that if I have a power raised to a power, I multiply. And so I'm going to have m minus 9 equals, and I'm going to go ahead and do my distributive property here. I am going to move this 5 over, so I have negative 4m, and then I'm going to add 9 over to the other side, so that's going to give me 24, and so it looks like m is negative 6. Right, similar process over here. Number 8, our base is 12. I do need the reciprocal here, and so I know I need to multiply by negative 1. So I know 12 to the negative 1, and then we still have our 4x plus 3. That's going to be how we need to flip over that exponent. And then notice I am going to have to add some of these exponents together because I am multiplying with like bases. So if I rewrite all of this without the 12s, I'm going to have a negative 4x minus 3, and then I'm going to add to that x squared. And then that's going to be equal to 2x plus 3. And so let's do some rearranging. I'm going to put x squared out front. And then I need to move my 2x over. And that's going to make that negative. Along with the negative 4, so that's a negative 6x. And then subtracting 3, so that's going to give me a negative 3 minus 3, so a negative 6. And that equals 0. I just noticed I miswrote this. This should be a 13. So if I subtract that over, that's a negative 16. Okay. Now I thought we were going to have to do quadratic formula, and I know nobody wants to do that. So this is going to factor here. And so our two solutions is going to be x equals 8 and x equals negative 2. Now the fun and games gets even more serious. We are going to have to work with both sides. And so notice both of these, there's 7 to some power. So again, we don't need to change the value. We just need to change what the number looks like. So let's see, 7 raised to the third power. That's the same value as 343. And then I already had 2n minus 4 there, so I'm going to have to multiply those. And 1 over 49, that's the same thing as 7 to the negative 2. And I already had n plus 4 there, so I'm going to multiply. So our distributive property here, we're going to have 6n minus 12 equals negative 2n minus 8. Collecting our n's on one side and our numbers over on the other. So let's see. That looks like n is going to be 1/2. Okay, moving on to our next example. Now this one we're going to break this all the way down to 2 because you always need to go to the very lowest base you possibly can. And so for this one, 8 is going to be 2 to the 3rd. And I'm still going to incorporate that 2 minus v. And 128 is 2 to the 5, 6 maybe? Nope, to the... And we still have v plus 3 there. So again, our distributive property, so we're going to have 6 minus 3v equals 7v plus 21. We're going to subtract that 7v over, so I have negative 10v, and I'm going to subtract 6 over, so that's going to give me 15. And so it looks like for v, we're going to have negative 3/2 after you reduce it. All right, so it is possible to have work with both sides. So here's another good example of that, number 9. And here again, it looks like we can break this all the way down to a 3. So 3 squared is going to be our 9. So, and then we still got to multiply that by negative p that's already there. And 3 to the 5. 3 to the 5th. I need a calculator. Okay, and so here again we have negative 2p equals 10p plus 30. And moving our 10 over, so we're going to have negative 12p equals 30. And then we're going to divide by 12, so p is going to be a negative 5 over 2. Okay. Our next problem, again, keep going. I understand 4 is common here, but we need to go all the way down to a 2 if we can. And so for 1/4, that's going to be 2 to the negative 2. Negative to flip it over and square it to make 4. And then I already have 2x squared minus 6 there. And then to flip over 64, negative, and then 2 to the 4, 5, 6. And we need to make that negative times 2x squared minus 5. And then distribute our distributive property. So negative 4x squared plus 12 equals negative 12x squared plus 30. I will be adding 12x squared over. So I'm going to have 8x squared equals 18, and so x squared is going to equal, we're going to end up with 9 over 4, and when I do the square root of both sides, remember you do need plus or minus, and that's going to be 3 over 2. So our next base that we would need to work with is going to be 6, and so here we are going to change both sides. So 36, I would say, well, that's 6 squared, and I already have my 2r, times, and 1 over 36, 6 to the negative 2, and 216 is going to be 6 to the 3rd. And now let's put together, using our exponent rules, we know that's going to be 4r, and then plus a negative 2, so minus 2 equals 3. And so here we're going to add 2 over, and we're going to divide by 4, so r is going to be 5/4. Number 14, we're going to be using 5, of course, for these. So this is going to be 5 squared raised to the a, so I'm just going to write 5 to the 2a times, and for 625, let's see, that's going to be 5 to the to 4, I think. So we're going to have 4 times a plus 3, and then equals, and we're going to flip over that 25, so that's 5 to the negative 2. And so putting this together now, we have 2a plus, and we're going to have 4a plus 12 equals negative 2. So we're going to have 6a equals negative 14. And so we're going to divide both sides by 6. So a is going to be negative 7 thirds. Continuing on, for 16, 1 over 16, we know 16, all of this 16, 64, and 32. These are all 2 to some power. So to flip this over, that's going to be 2 to the negative 4. Then that's going to be times x plus 7. Times 2 to the 6th is 64. And we still have our x plus 5. Equals, and then 2 to the negative 5. That's 1 over 32 raised to the 4th. So it looks like we have negative 4x minus 28 plus 6x plus 30. And that's equal to negative 20. And so combining our like terms, we have 2x. And then we're going to have plus 2. Combining those terms equals negative 20. We need to subtract 2 over, so 2x is negative 22, so x is negative 11. Okay, our next example, again, looks like we're going to be able to use 2. So for 512, looks like we're going to have 2 to the 9th, and then we have our y squared already there. For 1 over 64, that's going to be 2 to the negative 6, and then times that 3y, and then 2 to the negative 3 times 5y squared. So let's put together what we can. We know from this left side we have 9y squared equals negative 18y plus, and then this is going to be negative 15y squared. So we really have 9y squared equals negative 18y minus 15y squared. So this is a good review of algebra. We do need to go ahead and get everything together that we can. I would add 15 over, so I'm going to have 24y squared, add 18y over, equals 0. Then we can factor, and it looks like we could probably factor out a 6y. And so we're going to have a 4y plus 3 left. Setting each part equal to 0, well, 6y equals 0, so y is 0 here. And 4y plus 3 equals 0, so y is negative 3/4. All right.